Mr. Boer here for part three, gravity. I left off talking about tides. About to talk about tides and why do we get tides per se, high tides, low tides, and that has to do with because the difference in the gravitational pull. We find any fluid, the difference between one side of the gravitational pull and the other side will actually cause it to like squish and elongate. So if we're looking here at why we would get, here's the Earth, which has a fluid ocean water planet on the surface, and then you'd have the moon. There's a gravitational force between the moon and the Earth. Two large bodies create enough gravity to keep the moon in orbit. We also get the fact that there is going to be a gravitational force between here and here, which we have a distance squared, right? But we're also going to get a different gravitational force all the way on this side. That's what creates the actual tides. And why do we get two high tides and two low tides is because the Earth is spinning this whole time. So you get a high tide where you're facing. You would also get a high tide on the backside. And then in between the other 2 points, you'd get your low tides. So you'd always have two high tides, two low tides for every day, every 24-hour period. So we also get times when the moon, the sun, and the Earth are all lined up together, because now we have another gravitational force between the sun and the Earth. We get a gravitational force between the moon and the Earth. And when they're all in the same line, we get higher than average high tides, and we get lower than lower average low tides. And we call that a spring tide. We get the highest highs and the lowest lows because we're getting an extra boost from the fact that the Earth and Moon created a tide, but we also get the sun and the Earth creating one. And these will only happen at new and full moons. So it can happen here or it can happen here, depending on where. As long as the sun, the moon, and the Earth are in the same line, this one would be a full moon over here because it's reflecting the light. We'd have a new moon, no light on this side. That's all astronomy. But they're all in the same line, so we'll get what's called a spring tide, higher than average high tides and lower than lower average low tides. You obviously would get the exact opposite if the moon, the sun, and the Earth all form right angles. I must have missed it. I must have missed that one. But imagine, oh yeah, it is here. Sorry. Sun and Earth, they form a tide, but then the moon and the Earth form a tide. They help to cancel each other out. So you get it higher here, you get it higher here. And so we actually get lowest high tides and the highest low tides, the least amount of difference between them. And those will be called neap tides. So you got spring tides and neap tides along with your two high tides in a day and two low tides in a day. But that has to do with the gravitational pull between two different surfaces or fluids, which means you technically get a tide in lakes because one side of the lake has a stronger gravitational side than the other. There's just not as much of a difference, so you get really small differences or small amounts of high and low tides. One of the other objectives we talked about was black holes, and what basically any star has gravity pulling it in towards its surface. All the gases in the star are being pulled towards the surface because that's the strongest gravity. But the star also has nuclear fusion pushing it out. That's what makes a normal star. It's the balance between nuclear fusion pushing out and gravity trying to pull this star in. It's a gas. It's not a solid like the Earth has where it's a rigid and it's enough to stop the inward pull of gravity. These gases want to keep coming closer together. But as they come closer together, they heat up. And if they get hot enough to fuse hydrogen, they push back out, and that's nuclear fusion. So that's the kind of combination, the battle that takes place within a star. And that's eventually, though, the star runs out of fuel. And what happens when the star, this white arrow is pushing out end? Well, gravity takes over and it pushes everything in. If the star is large enough, it can form black holes. If the star's not large enough, then probably the electrons bumping into each other as two atoms come closer together, the electrons are negative of each one. It's enough to stop. And there's different remnants. There's neutron stars, but it's enough to stop. It just becomes a very dense star. But if that electron repulsion isn't enough to stop the inward pull of gravity, in other words, gravity is stronger than the electron